Hey guys, do you know what's the difference between an immutable variable and a constant variable in solidity? Well, let me tell you with an example. So it's a demo concept which I made just to demonstrate the difference. As you all know, both the variables can't be changed in the later words with any function. So what's the actual difference? So the basic difference being the constant variable has to be defined and initialized at the same time, while an immutable variable can be defined and can be initialized with the constructor. But there's more to it than just how it's been initialized and like defined and initialized, which is how it's been stored. So both of the variables are stored within the bytecode of the contract. So I have deployed this contract, and here's the bytecode for this. The deployed bytecode, here it is, and here's the better representation of this bytecode. So I can demonstrate how it's been stored, which has a big difference. So immutable variable is defined once within the bytecode. So I have this deployer, and it's been initialized as a message.sender, and as you can see, this address is present in this bytecode once. And how it's been accessed is whenever a function trying to get the value of the deployer, it points towards this special runtime bytecode slot and get the value from that. So they have opcodes which points towards this special memory, which has a different slots than all other variables, like this public variables. They follow the other slots, and this has another slots. And a constant variable are much more efficient than an immutable variable because they are hard coded with every function. So as I initialize this as with the 111 address and and I'm accessing this variable at this function, and as you can see, it is there in the bytecode at least twice. So as you can see, the 73 address, which is push 20 push 20 opcode. As you can see, push 20 pushes the 20 byte value onto the stack, which pushes this address to the stack. So because it's an address, right, that's fine. So as you can see, this is been hard coded with the functions also, and it's get much more easier to access those constant variable because it is being hard coded with the function. And if you try to call this constant variable like 4 to 5 times, and you won't find it 4 to 5 times in the bytecode, because compilers are smart enough to not just hard coding it every time you call it, because they can do a copy paste opcodes with these variables. So, but you're gonna see them at least twice if it's in a constant variable. And a fun fact, I got into this rabbit hole because I was exploring these Uniswap contracts, where I found out they are using no delegate call modifier for almost all their functions. So as you can see, this modifier is being used with all these functions, and even with the factory contract where it's been initialized. As you can see, here is the modifier. So why is it really there? Why are they preventing the delegate call from other contracts? So it's because it's for a reason, because how Uniswap stores the pool information into a storage slot, which is at storage slot 0. So if you are calling the Uniswap contract to create a pool, and if you are doing it with a delegate call, which will happen in, like, if you want to create an pool, and if your slot 0 is already occupied, then it will just use another slot, and it won't work because Uniswap stores this in the slot 0 location only. So in order to prevent that storage collision, they actually have this no delegate call modifier with all those functions. So to avoid this just a storage collision, and they store it in a storage slot where it can be accessed very easily, as you can see, and go to the pool state interface. And you can check out why they have used to save, like store it in a slot 0 to save the gas, and they have added this no delegate call also, just to prevent that storage collision. So you can read this to get more clarity. And I would like to give you some insight which I found out was there's an with all the function signature, with, like, these are all the function signature in the bytecode. Obviously it will be present in the bytecode, and you can see that 8063 will be there in the prefix of it, and 1461 will be there at the postfix of it. So if you want to easily just get all the functions of a contract which is not verified, you can easily get it by getting this searching about this opcode. So 80 and 63 are two opcodes which are present before the function signature, and 14 and 61 is after the function. So it's easily identifiable from the bytecode. I have checked this in multiple contracts that 8063 and 1461 are there in the function in the contract bytecode, so it can be easily identified. I checked this for the public function in many of the contracts. So fun fact to know. And other fun fact is every contract are being every contract's bytecode has this 60, 80, 60, 40 at their initial line. So it's just storing all the block ID and all such information. You can look out in this website for all the bytecodes, what that bytecodes do and why it is there in your contract.